In this question here, we are told that 1 over sec x minus cosec x plus 1 over sec x plus cosec x is equals to 2 cos x over 1 minus squared x. Now, how can you be able to prove that the left-hand side is the same as the right-hand side? Now, in order to prove this, we're going to use the left-hand side to show the right-hand side. So this is going to be left-hand side to show right-hand side. So which means that we are going to begin with this part and we try to check whether we are going to arrive at what we have at this beta end. So is these two terms multiply together. So we are going to have sec x minus cosec x multiplied to sec x plus cosec x, like that. So meaning using butterfly method, this term will be multiplied here and this term will be multiplied here. So we are going to have sec x plus cosec x plus sec x minus cosec x. Now, this expression that we have here, you can see that this term and this term is going to cancel out. And then we're going to have this expression reducing to 2 sec x divided by sec x times sec x is going to be sec squared x. Sec x times cosec x is going to be plus sec x cosec x. Cosec x times sec x, this is going to reduce to minus sec x cosec x, and then cosec x times negative cosec x times cosec x here, this is going to be cosec x squared. So we shall have minus cosec squared x, right? Cosec squared x. So all right, so having this, again, we can see that sec cosec x will cancel out, and this is going to translate to 2 sec x over sec squared x minus cosec x, cosec squared. But you need to remember that sec x is the same as 1 over cos x. Cosec x is the same as 1 over sine x. So we can be able to write this as 2 over cos x, because sec x is 1 over cos x. So I'm transforming this to that, over 1 over cos squared x minus 1 over sine squared x, like that. So the next thing I'm going to do, I'm going to multiply all through. I'll multiply this term at the denominator and at the numerator. I'm going to multiply by cos squared x. So I'll multiply here by cos squared x and here by cos squared x, like that. Let me write this x properly. When that happens, we can see that our equation is going to reduce to this. Cos x is going to cancel with 1 of the cos x at the top, and then we're going to end up having 2 cos x remaining at that point. And if you multiply cos squared x times 1 over cos squared x, we're going to have 1, because that will cancel out. Because if you're having 1 over cos squared x times cos squared x, these two terms will cancel out, and we're going to have 1 at that given point. Then we are having cos squared x times sine squared x. So if you're having cos squared x times sine squared x, that's going to be cos squared x over sine squared x, and that is actually 1 over tan squared x, which is actually cot squared x at that given point. So meaning this term becomes cot squared x at that point, and now this becomes the final answer which we were told to show at this given point. So we can be able now to say this is now QED, which means quod erat demonstrata, which means that that is the end of the proof.